First and foremost, I would like to welcome you all. Now, if there are any kind of a question during presentation, you're more than welcome. Or if you would like to make any kind of discussion later on, we can do it in the Q&A session. First and foremost, let me just introduce our company. I'm here representing two of the companies that I am working in. The PİNHAS. We are making distribution of the plastic raw materials. Clusters, master batch are our expertise. And in the last period of time, in composites and the single-wall carbon nanotubes, which have become quite prominent nowadays, are actually the subjects of my presentation. We have been established in 1939, and since mid-1960, after the plastics started to become more commercialized, we started making imports. In Tahtakaya, the importation has initiated. Unfortunately, in Turkey, it has never actually met the needs of the Turkish plastic raw materials, and it has grown each and every day. So right now we are still continuing giving service to 5,000 different companies in the country. We are basically working in a group of commodity, which Petkim also produces, polyethylene, stretits, and other materials as well, additional materials as well, and engineering plastics, and indeed special plastics as well. There are approximately 40 employees working in our company, and we have offices in 3 different distribution offices in Turkey. In a sales network, we have 12 chemists working. We are making distribution to Arkema, Pebax, Alto Glass, and Konstab, Kapot, Kafrit are our main representations. In commodity, Rexon, ExxonMobil are the companies that we are making the distribution of. Our main office and our warehouses are in Istanbul, and we are giving service to the automotive sector, and that's the reason why in Bursa we have chemists and engineers. In Izmir, in the Aegean region, and also in Antalya, we give the necessary services. Today I'm going to be talking about the single-wall industry scale single-wall carbon nanotubes. Well, we have in Novosibirsk in Russia. We're still continuing to make the production. Actually, this has been an invention of 3 scientists, and that process has been patented. And an industrial investor believed in the material and invested in it. On 2013, it has started to be produced and distributed in the world. So this single-wall carbon nanotube is distributed under the company OCSiAl. So we are making a very fast research and development, and we are giving a response to the questions that pop up. And we constantly change ourselves. The investment that we received is $500 billion, and the production that we have made is increasing through the years. So on 2022, we will reach up to 3,000 tons. And when we actually met this company, it was at a startup company, and the capacity and the places of innovation grew very fast, and the projections show us that this company is going to grow even more. And in all sectors and globally, the marketing of these products, their own offices, and through our distributors like us, the technical marketing and the approval processes have been followed. And it has indeed, the tube ball has exceptional properties. It has a thermal stability. It is 100 times stronger than steel. its surface area is very wide. 1 gram equals to actually 2 basketball courts. And the diameter of the material is 1.5 to 2 nanometers. This tube is 1.5 to 2 nanometers, and it has an aspect ratio of more than 5,000. In each volume that it enters in, it creates a 3D structure. And compared with other contributions, the material, with its net, which is 3 dimension, has 110 out of 10 from carbon fibers, 1 out of 200, and for carbon powder at about 20%. When carbon black, when you add 20 to 40% to it, the mechanical receptors are very high. It gives us a great advantage in weight. Rather than contribution, it's actually additional contribution to the material. The high quality and very conductive single-wall carbon nanotubes, the SWC anti-content is more than 80%. And in general, within the material, there's a very low amount of amorphous carbon at about less than 1%. And the encapsulation of virtually of all inorganic impurities. It is not easily degraded, which is one of the most important features of this material. You can see the electron microscope visuals of the material. You can see what type of a fiber structure it has, and you can see that it is actually connecting to many parts. When it is a little bit added, it creates an electrical contact. Here in this photo, you can see here the inner of the material is actually void, and the surface is very homogeneous. Compared with the multi-scale carbon nanotubes, there is actually a problem of
söz konusu olmadı.
There's actually the challenge of pelletizing. There's agglomeration, lumping. But now in this material, there's no lumping at all, and it is distributed evenly. You can see the graph of what I've shown you, the carbon black, the metal fillers, carbon fibers. And you can see here in between the morphological differences on these fillers and the fibers. So metal and carbon black are quite striking because in general, geometrically, these are non-spheric fillers, and their contact possibility and areas are less compared to fibers. When you added these fillers at a higher amount, then you can actually achieve a contact. And 1 unit in the volume and the other nanoparticles, you can see how they are located. The carbon black, for instance, can be counted by the eye. And the carbon fibers, if we can actually enlarge it you can enlarge it and you can just count it. But the carbon black, which is only added by 0.01, is creating a 3D net and doesn't create any kind of a space in between. But due to the contact area, the whole performance shows itself after out of 1 to 1,000. But the cost here is also decreasing if you follow these steps, follow this type of utilization. Now here, after the material is matured in the market, it is said that this is going to affect the industry by 70 to 80%. It is going to be used in metals, in cement, in ceramics. For the time being, it's been used in thermoplastics. For the time being, excuse me, no marketing has not yet been made because the company is almost at the end of the startups. And that's the reason why it is looking for the different types of ways of marketing it. Now, elastomeric materials, and aside to that, on composites, the company is making a very serious marketing. And what might be interesting for you, there's some certain applications that I want to show you, which the details are going to be landed to you after a certain period of time. Now you can see here the tires. These are industrial and normal cars, epoxy laminates, and all composites, all thermoset materials can actually have this material. Plastic and glass screens, lithium-ion batteries are also included in this. All modern and advanced materials can actually adapt itself to it. Since it has an ultra-low loading, it doesn't actually create much of a problem as far as we know. The effects are quite positive. As for plastics, there are self-resistant features. Anti-static features are actually migrating on the surface. But now, due to humidity and due in time, with a non-corrosive way, the anti-static features, and even for EMI shielding, this is a material that can be easily used. 10:4 is shown here, but 10:2 is what we have achieved. 10/2 has been achieved. When the company first started producing, Tubal had a standard reactor exit, which was actually a powder. But the agglomeration is it can be lumpy very easily, and that's the reason why the solubility was a little problematic for it, and that's the reason why the company decided to do something else. Now they have started to present it to the market with 10% of concentrations, and these 10% of concentrations are actually the base is dispersing the base chemicals. There are also water-based, plastifide-based, and special and different special chemistries can also be included to it. It totally depends on the company's needs. And you can do it also tailor-made. Now let us talk about success stories.
Çeşitli açılardan
Not only in the composites, but also I want to talk about success stories in different materials as well. Even though we talk about the composites in the second part, the thermoplastic materials, however, on the other side, are going to be widely used in composites. The thermoset composite producing companies are following these developments very closely because the recovery of thermoplastics is now questioned for a little bit. Now let us start talking about coatings. As for coatings, this 10% of concentrations are here enlisted in which type of chemicals they are solved. Epoxy, polyester, vinyl ester, polyurethane, acrylic, melamine, and phenolic resins. The solvent-based, according to non-solvency, the tubular matrices have been enlisted here. For instance, for non-solvent epoxy, fatty acid glycerol ester-based, which is a plastifiant, matrix 203 is suggested. It's dissolved in the system, and it doesn't cause any kind of a problem afterwards. It adapts itself wonderfully. If that doesn't work within a system, then as an alternative, ethoxylated alcohol can also be added in as a base for the 10% of concentration. Antistatic coil coating, by the way, the yield, taking a look at the yield, and the 6 to 3% of carbon black replaced with 0.2%, tubular matrix 201 has been used, and through that the material has a good conductive performance to 10/7 to 10/9. This producer is a coating company in China, but on the other side, it is also has been approved in the United States as well, not only in Asia. And the producer in Russia is working on antistatic epoxy floor. It is actually, these are the antistatic epoxy. These antistatic epoxy floors are used generally in factories, and they are black. Even though there's a 50% of fiber, it is converted into a black, and it actually darkens the area. But the electrical it is quite possible if when you use that type of a material in such dark factories, it is quite possible that you can actually receive some type of an actually light. And antistatic polyurethane coatings. Now it is 15% of mica powder is replaced with 0.2% of mattress 203. This is an application done in Malaysia. You can see that the environment is a light gray. For the epoxy primers, 6% of conductive carbon black is replaced with 0.5% of matrix 203. When it is done so, then a 10/4 to 10/6 is achieved, and the permeability can be increased. Here we can talk a little bit more about some other issues that might interest you. The antistatic fiberglass tanks. The carbon black is used by 10 to 15% and replaced with 0.05% of tubule. So with almost a non-utilization compared as for coast, it is quite possible to create the conductivity. This is a fiberglass tank manufacturer in Europe. By the way, rather than, let us say that you use 0.1%. All these numbers, if you use that number, that means that how much coils have been used on that, or bonds on that truck has been used, you can actually decrease the number of it as well. That means that also the lightness of the of the material of the vehicle. So you can actually save time at about 10%, and you can increase also the manufacturing. Even though the kilogram price looks higher, due to the other factors, it is actually saving you money. Antistatic GVRP pipes. These are industrial pipes. And in industrial areas, an X-proof, resistant, explosion-resistant materials, we can call them. These are carbon black. With this material, the carbon black is replaced with 0.2% of mattress 201. You can actually color them with a paint, whichever you would like to. It can be yellow, blue, or green, any type of color you would like to use. You don't need to make an additional painting over it, and the antistatic feature continues. In gel coats, if the carbon black is 5%, 0.1% tube, if we add 0.01% tubal, then the conductivity performance is actually decreased to 10/4 and 10/5. Similarly, in SMC composites, there are successes as well. This is received by a Russian company. A 6% of conductive carbon black is replaced with 0.1% of mattress 201. It's a 10% of a concentration, as you know. The single wall carbon nanotubes is added only by 0.1%. The conductivity and the antistatic is in the interface of the antistatic gap. And in industrial presses, could be newspapers or could be books, for instance, and either textiles in these systems, so now it's with a 17% conductive carbon black, and when it's replaced with 0.4% matrix 201, you have a conductive performance at 10/6 for the printing rolls. The mechanical performances that have been fragmented, or instead of a roll that is not that resistant, you receive a better resistant material. And then no problems or fire risks occur. When we talk about cable connectors, outer conductive layers, and graphite dispersion in toluene replaced with 5% of matrix 601 creates a conductive performance at about 5,000 omega.
Yine aynı üreticinin bir başka malzemesine dair örnekleme yapılmış.
And then now these are also other data from another company. Since we're talking about elastomer, most of the tire producers are making research and development studies on single-wall carbon nanotubes, particularly in industrial type tires. Approval period is halfway longer than normal cars, so that's the reason why they're coming almost to the end. So the resistance towards any kind of wearing or any kind of a loss due to wearing is 50% better due to the single carbon nanotubes. And besides, you can paint the material, and that's the reason why the tires should not always be black. And I'm sure that we are going to see such samples, such examples in 1 or 2 years. And I suppose we're going to pay a lot of money for that as well. But if you take a look to our website as well, and the cost of tire, it will only add $2 or $4 of an additional amount to the tire. And there's also pressure sensitive adhesive films, could be in plastics or in glasses. The utilization of carbon nanotubes is increasing the conductivity, and it also it improves the decisiveness of the material. On the other hand, as a synergist, it is possible to actually reach to areas that you have never actually reached before. Latex gloves, again, have a good conductive performance with this material. When you use it in a very low amount, the antistatic or electrostatic dissipative levels are decreased, and it is quite. It is also adapting to the European norms. I told you before, in the industrial applications, there is a European manufacturer for this type of a production, particularly it is preferred by such European companies due to its resistance and conductivity. This is an interesting product, but OCSiAl investors, as you can see here, have been the investors of the scooter that you see nearby, because all the performances have been tested in wet areas. They tried to make the scooter fall. Whatever they did, it didn't work. With just this technology, of course, the carbon fiber and the nanotube has been used as a synergist as well. That caused to reinvent a new scooter. This is called U-Jet. U-Jet. I suggest you take a look at it as well on the internet. The first videos will be very interesting. It's a very interesting design, and all system has an electrical conductivity. And the way it actually catches the road is really good, and the braking distance is much more reduced than normal. As it is used also for rotational moldings. Indeed, the carrier is different. The different codes, like 801 is linear, low linear polyethylene wax. And here, there's all types. While you are producing all types of materials, indeed, in many axes there are different movements, and dispersion is a process itself, and it makes everything more homogeneous. And due to this, due to the rotation, all these big parts can be used easily in where there is actually an electrical conductivity. This is the presentation that I can share with you. If you have any question, you are more than welcome. If you would like to get into more detail, I would like to present you my business card, and later on we can talk at a different platform. Thank you.